Hey guys, so in this lesson we're going to do something what I call neat algebra. Okay, these are algebra questions that are kind of set up by the makers of the test so that it kind of works out very neatly. Okay, or sometimes it's actually pretty neat. So many of these questions, there are roundabout ways to go about solving for them, but if you can identify what kind of problems these are, usually there are some shortcuts that you can take to do it a more neat way. Okay, and so let's go into some practice questions here. Again, I have for this lesson as well in your material section, you'll see a PDF document of the neat algebra questions that you may find throughout your official College Board study guide. Okay, so you can find that list here. So we're going to do the first couple questions. I'll do about 10 questions with you, and hopefully the remaining questions you'll be able to do on your own and hopefully get them right. We're going to jump to test number 1. And I'm on test 1 here. Test 1, section 3, number 16 is what we're going to do first. So let's go to section 3, number 16. All right, so here we are. In number 16, we have if 3a plus 4b equals b, which of the following must equal 6a plus 6b? Notice they're not asking for a, they're not asking for b, so we don't need to solve for anything here, okay? We just need to take the information that we're given, which is this guy here, right, that equation. And one of the things that I teach in my course is to, whenever you're given any sort of information, always simplify them. Okay, before you read any further into the problem, just simplify them. Okay, whether it's through factoring or just simplification, simplify it. So in this case, we see, right, some like terms. We can combine them. We can either take the 4b to that side or b to this side. I'm just gonna take the b to this side, subtract b on both sides, for the following reason. We're looking for something called 6a plus 6b, right? So what we're trying to do is to take what we're given, the given information, and rearrange that information to look like what they're asking for. So what they're asking for looks like they have a and b together, right? So that's what I'm going to do. I'm going to take the 3a plus 4b equals b, which is the given information, and make it look a little more like this by subtracting b on both sides. I get 3a plus 3b equals b minus b is just a 0. Okay? Now, I'm not going to simplify this any further by dividing both sides by 3 or anything like that, because what you'll notice is how can I get from 3a plus 3b straight to 6a plus 6b? What's the difference between these two expressions? The only difference is that this right here is just twice this one. So if I were to take both sides of this equation and multiplied it by 2, which means I would have to distribute here, right? I would get 6a plus 6b, and that would equal 0 times 2, which is still a 0. So to answer this question, 6a plus 6b, my answer would be a 0. A would be the correct answer for number 16. Let's go to test number 2. In test 2, let's go to section 8, number 10. Okay, so this is another neat algebra question. If x plus y squared equals 100 and x minus y squared equals 16, what is the value of xy? Now, do you see xy anywhere in this problem? We're looking for xy. We have a separate x, right, and separately a y. Same thing here, x separately and y separately, but we don't have the product of xy. So how can we find the product of xy? One thing you might be thinking right now, especially if you're okay with algebra, is maybe you can take the square root of both sides, right? So that x plus y is equal to 100. Now, when you do that, you have to be careful because whenever you take the square root of both sides, you have to take the plus and minus of that right side. Okay, same thing goes here. If you take the square root of both sides, you have to take the plus and minus. And so because of that reason, I don't want so many different cases coming up. I usually don't like to do that when there are other ways around it. Okay, it's not the wrong way to do it, but it's just not my preference. So what I'm going to try to do is this. I'm going to try to find xy. See, what I want you to understand is, even if you take the square root of both sides here, you won't get xy. All you'll get is an equation that says x plus y equals 10, and another equation that says x plus y equals negative 10. You still don't get xy. How can I find xy? What can I do to these given equations to find xy somewhere? Okay? I'm going to go ahead and FOIL this out. This right here, x plus y squared, just means x plus y plus another x plus y, and that equals 100. Right? This one right here means x minus y times x minus y equals 16. So if I were to FOIL this out, right, x times x is x squared, x times y is plus xy. And do you notice something? xy, xy, that's how I know I'm going the right way. Okay, this is the approach I need to take. So then I go to y times x, so that's another xy. Y times the y, that's a y squared, and that equals 100. Okay, so what I have now is x squared, I have a plus y squared. I also have 2 xy's equals 100 is what I have so far. Okay, let's see what we get here. X squared minus xy minus another xy, minus times minus is positive y squared, and that equals 16. Okay, so here I have x squared plus a y squared minus 2xy is equal to 16. Okay, so that's as far as I can go. This is what I have so far here. This is what I have so far here. Okay, so what can I do with these? Well, let's see if we can figure something out. I'm going to erase the top here so to make a little bit more room for me. But let me just rewrite these two equations up top, so it's easier to compare them. X squared plus y squared plus 2xy is equal to 100 is that first one. The second one is x squared plus y squared minus 2xy equals 16. Now let me erase the rest of this, since I have everything copied. What do you notice? We're trying to find xy. See, if we were to combine these two equations by adding them or something like that, right, you'll notice that these two guys cancel out, and while these don't. Well, that's not what I want, right? We want the xy to stay. And so rather than adding these two equations together, right, and it's called linear combinations. If you can remember this back to Algebra 1, we can subtract both sides, right, or multiply both sides by -1 and then add it however way you want to see it. You want to subtract, right, the two equations. And when you do, you get x squared minus x squared, which is 0, right? These cancel out. These also cancel out, right? When you subtract a negative number, that's basically adding, right? So we get 4xy, and that is equal to 84, right? So all you do now is divide both sides by 4, and you get exactly xy. So xy would equal 4 into 84. 4 into 8 is 2, into 4 is 1. 21 is the correct answer. C would be the answer for number 10. The next one we're going to do is in test number 3, but let's take a quick break. The next two that we're going to do in test 3 is section 2, number 6, and section 8, number 5. Okay, so see if you can go on to the next test, test 3, and try section 2, number 6, and section 8, number 5, and I'll pick up with you guys in the next video.